Now the rule for signed overflow states that if you add two numbers of the same sign and get a result of opposite sign, you do indeed have a signed overflow, which means the v bit equals 1 of n, z, v, and c. However, you can also get a signed overflow when you subtract two numbers as well. So let's take a look at that. For instance, 6a subtract 9f. 6 is a positive number because the most significant bit of 6 is a 0, which makes it positive. 9 is a negative number because the most significant bit of 9 is a 1. So what we have here is a positive, subtract, and negative. And our answer is CB, which indeed is negative because C starts with a 1 as well. So this is a positive, subtract, and negative, but the rule states that if you add, so what we have to do is convert this subtraction into a 2's complement addition. We don't have to do the math, we just have to rethink it. So if we have a positive, subtract, and negative, that's the same thing as a positive plus the opposite sign of whatever this is. So a positive, subtract, a negative is the same thing as a positive plus a positive, and our result here was negative, so a positive plus a positive giving a negative means indeed for this case we have a sign overflow in v equals 1. Now if we want to take a look at a binary subtraction, it's a little easier to see the numbers in terms of positive and negatives here. This is a positive, subtract, and negative. Very easy to see. Now to do the binary subtraction, we don't want to do a 2's complement addition. We can very easily just convert this to the equivalent hex subtraction, and so this becomes 5d minus eb, and very quickly we can come up with 72 with a carry. And all we have to do is then write this back in here. There's our carry here, and here's our answer, 72 converted to binary, and that's the quickest way to do binary subtraction. But what we have here is a positive, subtract, and negative as we had before, but our answer in this case is positive. So if we rewrite this as a positive, subtract, and negative to an addition, that's a positive plus a positive, and our answer is positive. In this case, v equals 0. So any subtraction can be rethought in terms of a 2's complement addition without having to do the 2's complement addition to see whether the v bit is 1 or the v bit is 0.